Hi, I'm Jake Sugden from Urban Workshop, and today we're going to be going over the Level 2 project of the electronics portion of the Marquee Star. So today we're going to be going over the safety, some of the tools that we'll be using today, the components of our project, and then the full assembly. So the safety portion of this project is mainly going to be about the soldering iron that we used back in Level 1. So this is an iron that gets hot enough to make certain metal molten, and it can go all the way up to 450 degrees. So we want to be definitely careful about keeping that away from our skin so we don't burn ourselves, but we also want to make sure we keep it on a stand so that we don't burn our table. We're working with very low voltages. We're just going to be working with some AA batteries, so there is no electrocution warning, but whenever you're working with any electronics projects, usually the main hazard is going to be either the heat from the soldering iron or any splattering from any of the solder. So the solder is going to be the molten metal that we can let cool and then merge two pieces of metal, whether it be a wire to another wire or a wire to another component, to glue them together permanently. And so just in case any of it does spring up and it sprays anywhere, we want to make sure we're always wearing glasses so it doesn't get anything in our eyes. So the first tool that we're going to be going over today is the soldering iron. So like I said before, this can get very hot. We're going to be setting it to about 350 degrees. So you want to set the temperature on here pointing up towards the very tip. So that 350 degrees is really crucial, because if you get it too low a temperature, your metal won't actually melt well enough. It'll just hold up into a bead and it won't actually fully relax and release all that surface tension. But if we get it way too hot, then we'll actually end up burning it. We may accidentally burn our components, and we just want to avoid that as much as possible. Make sure you always grab the rubber side and don't treat it like a pen and grab onto the metal portion. Whenever you see the red light on, it means that it is plugged in and there is power. So if you're working and setting up some other parts and you want to set this aside and make sure it's warming up, so by the time you get to it, this is ready to go, make sure that red light is on. The second tool that we're going to be using is the multi-tool. So this is an electronics multi-tool. It's got a pair of cutters at the very bottom, and then it's got a set of stripping holes. So whenever we deal with wire, it's going to be a strand of metal, or sometimes multiple strands of metal, that's then covered by rubber. And this is to insulate it electronically, but it's also going to protect it from any elements, any water, if anyone steps on it. And so to work with it, we need to take off that outer coating of rubber. And to do this, we're going to be using these strippers. So you'll notice there's a bunch of holes on the side of it, and they're numbered differently. So the lower the number, the bigger the hole. So we're going to be working with 18 gauge wire today, and we'll go over how to use these in a little bit, but just note that we'll be using the hole with the number 18 on the side of it. So whenever you get wire, it already has a layer of rubber over it, and we're going to be using the strippers on the multi-tool to take off that top layer of rubber to expose all of the metal underneath. But usually when you're working with a lot of projects, you'll have exposed metal, and so we want to add another layer of insulation to that. So there's a couple ways you can do it. You can wrap it in electrical tape, which is a special type of tape that doesn't conduct electricity. You can also use this stuff called heat shrink tubing. So it's a thermorubber, which means when you apply heat to it, it will shrink around any exposed metal parts, but it also does not conduct electricity, so it completely insulates it. And we'll be using that in conjunction with a heat gun. So this is kind of like an amped up hairdryer, where it's got an on button, it's going to blow out a lot of hot air, and we can just work really quickly while it shrinks all of the rubber. And it works relatively quickly. If you do it too much, you can actually end up damaging some of your electronics, but we'll go over that in a little bit. And then going down the line of the components that we'll be using, we have 2 AA batteries and a battery housing. And the battery housing comes with 2 wires, and these are pre-stripped and pre-tinned, which means they already have a really thin layer of solder on there already. But because we're going to be soldering these to a larger component, we want to strip these later down the line. We also have a switch. So this is just a push button switch. As you can hear, there is a little spring in there, and when you click it down, it touches two prongs together, which completes the circuit and turns it on, and then you click it a second time, and a spring releases these, which means that these two metal prongs are not touching each other, which means the circuit is open and you get no power, and in our circumstances, no lights. And finally, the most important component is an LED. So LEDs are really, really fantastic. They stand for light emitting diode. So in the electronics world, a diode is kind of like a one-way door where you can only put electricity in one way and it can't come out the other direction. So it's used on really big scale batteries where you don't want to be back charging it because you can have kind of dangerous consequences. But in this circumstance, this diode basically means that if we put electricity in the correct way, it'll light up. And if we put it in the wrong way, kaput. It's going to blow up. And it's not even exciting. It doesn't go, it goes, fizzes out, and you've basically just wasted an LED. So when I say that you put the electricity in the right way, I'm basically saying you need to attach the correct positive wire to the correct positive terminal, and the same with the negative wire to the negative terminal. So if you see on the LED, there is one leg that is longer than the other. So that long leg means that one is positive. And whenever I'm working on any of my own projects, just so it's a little bit more apparent, I always bend out the positive leg to make it a little bit easier to see. But some LEDs, especially ones that are sold in bulk, they're actually lopped off so the legs are the exact same length, which is incredibly annoying. And the way that you see which is positive and negative is by actually looking at the bulb itself. And on the negative leg, they'll actually grind out a flat portion of the bulb, meaning that it's negative. A really good way to think of it is that it's a flat line, kind of like a minus sign, so negative. And then you can also see, if you are really clever and you look at the very center of the LED, which side is positive and negative. But the best way is to literally just look at the legs. So whenever we work with these, that's the one to bend. So now that I've cleared off my workspace, I can now work on the LEDs. So this is going to be the portion where we'll be doing 5 at a time. So it is beneficial to do all of the first step to all of the LEDs and then work in kind of a industrial style where you do one step to all of them and then move on. But for this video's sake, I'm just going to be working on one LED and then we'll jump cut and show the rest of them done. Obviously, they'll all be perfect. But the first step would be to cut 6 red wires to 10 inches and 5 black wires. The other red wire will be used in the rest of the components, but for the meantime, we're just going to be working with these 2 wires. So like I said before, we need to strip off the outer rubber ends. So I'm going to be finding the number 18 on there, and I'm going to be putting in the wire to about maybe ½ an inch. I don't want to take off too much material, but I also don't want to leave too little. And ½ an inch is a good little sweet spot. So I'm going to be clamping on the scissor and then just pulling. Sometimes it can be a little kind of tricky to pull it off. Some good tricks is actually to wrap the wire around your finger and then pull. Another really good trick is to actually start cutting at about a 45-degree angle, just because it makes it a little easier to cut. So do that, wrap around your finger, pop it off. And same to the very last portion. And I would like to emphasize, whenever you're doing this, you'll have a tremendous amount of these little rubber bits, so make sure you clean your area before you continue. So now that I've got my two wires, you'll notice that there isn't just one single strand of metal all the way through. It's actually in a bit of a branch. So to get this completely in one section, we can just grab all the metal pieces and then twist the rubber around it. And we're going to get a nice organized little coil of metal. And this will make it a lot easier to work with down the line. So we can just do that really quickly with all of the rest of our wires. I like to grab the metal and then spin the rubber. It's a little easier. And done. So whenever we're working with electronic projects, red is always positive and black is always negative. And that's kind of a logic that goes from small hobby electronics all the way into bigger consumable electronics. So if you're ever working with a car battery, the positive is usually always going to have a red wire to it. So now I can wrap my wire around my LED leg. So remember, my longer leg, in this case my bent leg, is going to be positive. So I'm going to be wrapping my red wire around it. So when I'm doing this, I'm basically making a temporary hold. I'm going to be wrapping my metal wire around my leg, and it's going to hold it just for the meantime. And then as soon as I put some solder onto my piece, then it's going to hold it permanently. And as soon as I'm done with that, I should be able to give my two components just a little bit of a tug. And if they come apart, I know I need to re-go back and fix it. But usually, if you do a good solder, you should be able to pull it just fine. So a good way to wrap it is to actually hold the very end of the wire near the bulb and then wind the wire around the leg. And I want to do it tight enough to where it can hold itself, just like that. And I can do the same thing to the other wire. But I want to make sure that I don't cross any piece of metal across those two legs, because then we'll end up with something called a short. And this is a really important electronic component issue, is getting a short. Basically, electricity is lazy. It wants to take the path of least resistance. If you ever wondered why lightning doesn't come down in a straight line, it's because it's going into different pockets of air that have more pressure or less pressure, and it wants to find the easiest way to the ground. Just like in this, the electricity isn't gonna bother going all the way up, lighting up an LED and then coming back down. Or if there's a bridge that's even closer and has less resistance, it's just going to go all the way through that. So we want to make sure when we're soldering that we have a really good separation, that there's no metal that's crossing those in between. So this is holding. So now we can go over to the soldering phase. So before I actually start out soldering, I can use some tip tinner, and this will basically just take off the oxide layer on the end of my soldering iron. So usually when metal heats up, it attracts oxygen from the atmosphere and grabs onto it much more rapidly than if it was cold. Just like rust on steel. When you'll be doing welding, you'll notice that we'll be piping gas around it, and that's to push out any oxygen so that we don't get all the potted mess on our weld. Very similar sense, the tip of this was bright, silvery, shiny about 10 minutes ago, and now because it's been heating up and it's in the fresh air, it's actually gone a little bit grey and dark. And so by pushing it through a Brillo pad, we can get rid of all the big kind of physical chunks. And you can see right there, it's immediately shiny, but that oxide layer will disappear. And so now we can go and put it in a little bit of tip tinner, and this chemically takes off any oxidant. So that's all ready to go. We can now push these to the side. And I can now have my solder in place. So solder is basically an alloy of tin and lead, where when they're mixed together, they have the very fantastic property of having a low melting point. So we can make this metal go completely molten, liquidy, with just the energy from our soldering iron. And we're going to be having it in a nice, small, reasonable size, just so we don't damage the rest of this. and I'm going to be bringing my soldering iron in front of me and on the stand, so it's a little easier to work with. There's a common, very boring joke told by electronics people that to properly solder you need to have 3 arms, one to hold the iron, one to hold the solder, and one to hold the wire. But in this case, we are mitigating that by just having it on a stand. There's also another thing called helping hands, which is kind of a big, heavy brick with a bunch of arms with almost alligator clips on the side to hold everything in place. But that can be kind of annoying to set up, and I much prefer to have my soldering iron in one place, just so I'm not waving it around and I might accidentally burn myself, which happens all the time. So, got my solder, and what I'm going to be doing is laying down my wire with my coil of wire over it onto my soldering iron, and then I can touch my solder to that joint, and I want to get a really nice thin layer of metal all the way over it, and I can take it off, let it cool, probably take a couple seconds, and then I'll give it a little light tug and it should be perfectly strong. So I can lay it on there. So now the heat from the gun is now going into my LED leg and my wire, and if I let it sit for far too long, the heat will actually go into the bulb and can damage it. So I want to just put it on there for a small amount of time. So now I can touch it. You can see a little bit of smoke coming off, and I can just blow that away. And basically, I'm just putting on a little bit to form a nice even layer. I don't want to put on so much that it's forming a really big bead. I just want a nice little even coating. So I can now give that a little bit of a pull, and rock solid. So now I can do the same thing on the other side. Now I want to make sure that I'm not resting any rubber on the soldering iron portion, because rubber likes to put off a lot of not tremendously good breathable smoke. Touch it all the way around, and sweet. So now I have one LED perfectly soldered, and I can now give it a pull, and that is locked on as well. So now I am done with my soldering iron, and I can now get to the heat tube portion of it. So I only need about an inch or so. I want to be able to fully cover any exposed metal, and I want to go over the rubber portion of the wire just a little bit. So I can thread on my rubber tubing all the way to the top. And you'll notice that when I was actually wrapping my wire around the legs, that I had my wire coming off the end of it. A lot of the times I'll see people wrapping the wire or wrapping the metal around the leg of the LED and then have the wire come out this way. And it just means when they're putting this on and putting it into the final assembly, it's a lot more tricky. So I can now push this on all the way up to the LED. I can do the same thing on the other leg. And Bob's your uncle, Robert's your brother's mother. This is now ready to go. To finalize it, we need to use our heat gun. So we can do that right now. All right, so now I have my heat gun, and I'm going to put it on the level 2 setting. And now this just has a little fan and a little heating element that's pushing hot air over it. And you'll notice that I'm moving the heat gun and my components at the same time. My heat shrink wire is now wrinkly, a little bit shiny, and it is completely almost suctioned over my exposed wires. And this is now done. 4 more to go. Okay, so now that all of our LEDs are done, we have them wrapped, soldered, and heat shrunk, and they should be all perfect. But we don't know until the very end when we plug our batteries in, and if we do have maybe a faulty LED, maybe we have a short that we didn't see, maybe we just have some defects in some of our solder or our wire, or maybe in our technique. The LEDs may not all light up, so if you have one LED that is not working, you can always cut these 2 wires and then splice in a new LED as fast as you can. But for now, we're going to work on the rest of the electronic components and installing it into our star. Now, the very, very, very first thing that you should be doing with this is making sure that the button switch is inside the star. Because, and I've seen this many times, people will do their entire circuit and it's perfect, everything lights up, and then they realize, oh no, I soldered my button outside of it and now there's literally no way to put it back in the star. So when you were welding, you should have noticed that there was a very big hole in one of them, and that is so that we can put our button switch through there and then fix it to the frame with spring washer and then our fastening bolt. Now you don't want to tighten it super hard, mainly because it's just not necessary, but also because we want to be able to rotate that switch so that the two legs, the two terminals where the component terminates, we can actually spin this so then we can get access to the different points as we go along. So now the button is installed. Now we can focus on the battery housing. So we don't actually want to put our batteries in until the very end, because this can actually damage the batteries. We do need to focus on our two ends. So again, we're going to be stripping the two ends, just so you can have a little bit more wire to work with. And we're going to be using the very smallest hole on our stripping wires. So again, about ½ an inch. Because this wire is so thin, it is likely that you'll actually pull off the rubber and then some of the small fragile wires inside will come with it. So if that does happen, don't worry about it. Just cut it off and try again. Cool. These are all good to go. So the way this is all going to go together is we are going to start with the black wire coming off of the battery housing, and that is going to be spliced to all 5 of the black wires coming off of the LEDs. Those will then go to their respective LEDs, back down through their red wires, and we're going to twist all 5 leads into a single point. That's going to be soldered to the extra red wire that we have. Then the other end of this red wire and the red wire from the battery housing are both going to be going to either terminal on the switch. And then if everything is set to go, then as soon as we click the button, everything should be lit up. One important note that I will make is that when we're twisting all of the ends, whether it be the black or the red of all of our LEDs, we are going to be having exposed metal. So we're going to be using an even thicker version with a bigger diameter of the heat shrink tubing. So for the red portion, we can just slide that on beforehand, that's fine. But for the battery, for the black battery side, we want to put the heat shrink tubing on now, just so we don't forget. So as soon as we solder everything together, we can then go slip it on, hit it with some heat, and everything is good to go. So first things first, let's twist all of our red and black together. So I want to keep this relatively organized, but all these wires are perfectly long enough to reach everywhere inside our housing. So I just like to line up all of the rubber ends. There we go. And then twist it all together into one big knot. Because all the ends are metal, they're all conductive, they can touch each other, and we will complete our circuits. And we can do the same thing with all of our red wires now. And again, just keep it as organized as you possibly can. So now I'm just twisting together my red wires, and there we go. Everything is nice and organized, and give it an extra little twist. And these are now ready to be soldered. All right, so now I've got my black bundle done together, and I've got the stripped end of the black wire of my battery housing with my thick heat shrink tubing on there. I can now merge these parts together, and I have my soldering iron already prepped. It's already been heated up. 350 degrees should do it. And I'm going to be using the exact same technique that I did on the LEDs. I can lay my piece down on there, and because I have so many more wires, I'm going to be using a lot more solder. So I can let this heat up as much as possible. And a good little technique is touching the very end of my soldering wire to kind of the mating point in between my wires and the soldering iron. And I'm seeing all of my metal wicking, which kind of means it's being pulled through all of the little joints. And I've got enough on there. Give it a little second to cool down. And I can give it a tug, and everything is rock solid. And then when I slide on my heat shrink tubing, I can make sure that I'm slipping it over both of the rubber wires so I don't have any exposed metal. And then at the very end, I'll be able to hit it all with my heat gun and make sure it's all secured down. And now we can jump over to doing the exact same process, but with the red bundle and my extra red wire. So my extra red wire is actually a little short, and so I'm going to just strip off a little bit more. Again, give it a little bit of a twist, just because it's wrapping around a lot more mass. Beautiful. I can now bring in soldering iron. Got my solder. Gorgeous. Gorgeous, gorgeous, gorgeous. Oh, so now, let that cool for a second. Give it a little tug. Everything looks good. I can now slip on my heat shrink tubing, making sure it's over any metal parts. And now I have got an open circuit. So now before I actually plug it in and solder my two ends onto my switch, I can temporarily put in my batteries, join the leads, and if all 5 of my lights are glowing, then I can continue onwards. Good, and touch it. Hey, there we go. So everything works, my batteries are in. I can now solder to the 2 terminals on my button switch. And if you notice when you pick it up, there's 2 little holes on the ends of the terminals of my switch. And so it's advantageous to put the little wire through it, kind of hook it around, and then solder to it. That being said, it's very difficult, they're very tiny, a little hard to work with. So if you would like to just hold the wire next to terminal and then have a friend go in there and solder it together, that's perfectly okay. Okay, so before I put it on there, I can just grab some more of the small heat shrink tubing and slide it over both of my red wires. And now comes a slightly tricky bit. That is feeding it through the 2 holes on the wires and then folding them over so they're separated. So I actually like to do these one at a time, mainly because I want to keep this wire as perfectly straight out as I possibly can. It's going to make it a lot easier to be able to slide on the heat shrink tubing if it's in a straight line than if it's kind of got an angle to go around. If the heat shrink tubing is being annoying and it's not working for you, that's okay, happens to me. Just grab a little bit of electrical tape and wrap it around and making sure there's at least 1 layer in between the 2 terminals. So now with my wire in a straight line, I can now bring in my solder and my soldering iron, and I only need a tiny little bit. I'm just going to be touching the very tip of my wire into the wire. Yep. There we go. Lovely. I don't want to put too much solder on there, or else it'll kind of form extra mass that I need to work around when I push my heatsink tubing on. But this is perfectly fine. Now I can actually twist my switch over a little bit to get a better angle in there. I can do the same thing with the red wire coming off of the battery pack. So the reason that those lights were staying on, even though I was clicking this, was because I was accidentally touching the end of this wire to the end of the other red wire. That's a short. So, same exact situation. Heating it up. There we go. And there we go. Done. So now 2 wires are on there, and they're separated with enough gap that we don't get a short. Last thing to do is slide on the heat shrink tubing and hit it with a heat gun, and pop in the LEDs into the LED holders, and we're done. So those are done. I can work on my stage heat shrink tubing. And so this will secure everything together. And the last one. Lovely. Okay, and now I can push all of my LED bulbs into all holes. And so I find that pushing the LED plastic holder out a little bit, pushing the LED all the way in, and then pulling the assembly out actually works pretty well. Kind of clamps everything together. And here's the best bit about electronics. If it looks really ugly in the back, all the wires and organized are all kind of floating around anywhere, it doesn't really matter. It's all in the back. It is the ugly side of the Christmas tree rule. Or if you've got a bit where it doesn't look very good, that's all right. Put it to the back. There we go. Now I can just click my button again, and all my lights are still turning on. Good to go. Alright, and that was the electronics portion of the Level 2 Marquee Star project. I've been Jake Sugden. Peace.